Hi everyone. In this problem we're asked to find the change in volume in an aluminum sphere if the temperature changes from 30 degrees Celsius to 160 degrees Celsius, which makes a total change in temperature of delta T equals 130 degrees Celsius. Now, this time we're dealing with a sphere instead of something that has a length or a height, and the sphere is in 3 dimension. And so we will have to use a slightly different equation, which is an equation for volume expansion. And this equation is delta V equals beta times V0 times delta T. So there's a couple of things that have changed here. Delta V is the change in volume. Beta is the volumic expansion coefficient. And V0 is the volume of the sphere before the change. And delta T is the same delta T that we were dealing with previously, is the change of temperature. So we can find beta in a book. In the manual, there is a table for this constant, and if we look under aluminum, what we find is that beta equals 75 times 10 to the minus 6 degrees C minus 1. So this is beta, put it in blue. All right, and we already have delta T here, which was given in the problem. Now what we need to find is V0, the original volume of the aluminum sphere. And the only thing they give us is the diameter. But here I've drawn the sphere, and instead of using the diameter, we will be using the radius. The radius is half the diameter, and so we simply divide 8.75 centimeters by 2. Now to find the volume of a sphere, there is an equation. It's 4 times pi times the radius cube divided by 3. And so using this, we will be able to calculate V0. It is 4 pi times 8.75 divided by 2 cubed, and the whole thing divided by 3. And this is equal to 350.8 centimeters cubed. And that's because I forgot to write it here, but this is 8.75 centimeters, and that's the only unit here, so it gets cubed, and so we end up with a volume which is in centimeters cubed. And it's important to keep track of those units throughout this problem, or any problem for that matter. So now we found our V0, and we have all we need to complete this equation. So I don't have to rewrite it here, but we will be using 75 times 10 to the minus 6, the beta, times V0, which is 350.8 centimeters cubed, times temperature of 130 degrees Celsius. And the result of that is 3.42 centimeters cubed. Now what the question asks is, what will be its percentage change in volume? So to find the percentage of change in volume, what we need to do is divide the change by the original volume, V0, which I was drawing red. And so delta V being 3.42 centimeters cubed and V0 being 350.8 centimeters cubed. Oops. What we have here is 0.98%, which is also the answer given by the manual.